Using observations from a NASA suborbital rocket, an international team of scientists has, for the first time, successfully measured a planet-wide electric field thought to be as fundamental to Earth as gravity and magnetic fields. Known as the ambipolar electric field, scientists first hypothesized over 60 years ago that it drove how our planet's atmosphere can escape above Earth's north and south poles. Hello, Inspired Earth. I hope that you guys are having a great week. We're going to start off with Saturn's rings vanishing and then go on to NASA discovering a third global energy field as fundamental as magnetism or gravity, they said. And then they've discovered that human mouth bacteria has a rare form of cell division, as well as a new Earth discovery about a donut in the Earth's core, and some photos of the moon, apparently the most advanced photos of the moon ever taken. We'll talk about that, and then we have a rescue at the end. So we're going to start off with Saturn's majestic rings will vanish in just 6 months from now, which is kind of clickbaity, but I'll explain. But before I do explain, does anybody remember when this first started coming into the headlines like a year ago or so? And I could have sworn they said it was going to be like July or August that Saturn's rings would vanish. But now they're saying that it's going to be March 2025. I'm just kind of curious if anybody else remembers them saying that it was going to be in the summer. I mean, it doesn't really matter. I just found that to be strange. But so I'll start off the article here. Most people consider Saturn's awe-inspiring system of rings that encircle the gas giant to be the most fascinating and iconic celestial feature in our solar system. Back in the 17th century, Italian astronomer Galileo Galilei first spied Saturn through his ancient telescope. He compared the planet's appearance to having ears due to the limitations of his device. The diligent work of scientists like Galileo has laid the foundation for our modern-day ability to explore the incredible wonders of our universe. Over the years, advances in technology and innovative techniques have empowered astronomers such as Dr. Lucy Jones from the esteemed Harvard-Smithsonian Center of Astrophysics to delve deeper into the enigmas of the surrounding celestial bodies. Through cutting-edge research and observations, they have unraveled the intricate mysteries of Saturn's rings, revealing their composition and the dynamic processes that shape them. A fast-approaching and significant cosmic event will soon dramatically alter our view of the magnificent planet. Come March 2025, Saturn's majestic rings will become virtually invisible to Earth-based observers. This phenomenon occurs due to the unique tilt of Saturn's axis, which will position the ring's edge onto our line of sight. As a result, this is a rare opportunity for citizens and astronomers alike to witness this celestial transformation, while also reminding us of the ever-changing nature of our universe. Thankfully, this isn't a permanent change. It's a fleeting cosmic event that it reoccurs every 29.5 years. Which is how long it takes Saturn to orbit the Sun. After March 2025, Saturn's axial tilt will bring the rings back into view, then vanish again in November 2025. So that's kind of what I meant with it. It's a clickbait title. It's not going to be a permanent change. So they're not really disappearing, but rather playing a celestial game of hide and seek. At their reappearance, we can also enjoy an accentuated view of Saturn's moons. So what are Saturn's rings really made of? Mostly they consist of ice particles, rocky debris, cosmic dust, creating a stunning spectacle visible from Earth with a telescope. Picture a bustling city with buildings of all sizes. Similarly, the ring particles vary from tiny grains about to the size of sand to chunks as big as houses or even school buses. This mix gives the rings their intriguing look. And the Saturn rings aren't just one solid structure. They're made up of several distinct sections, including A, B, C, and D, E, F, and G, which are harder to see. These sections are separated by gaps, like the well-known Cassini division between A and B, which is around 4,800 kilometers wide. The shapes and setups of these rings are mainly shaped by gravitational interactions with Saturn's many moons. So this is where we get pretty interesting here, with some of the moons, dubbed shepherd moons, hang out near the edges of the rings and help keep things in shape by pulling out the ring particles with their gravity. As for how Saturn's rings came to be, that's still a hot topic among astronomers. There are plenty of theories, from being the leftovers of a destroyed moon or a comet that got torn apart by Saturn's strong gravity, to materials left over from when Saturn was formed over 4 billion years ago. Each theory has its own fascinating ideas, and ongoing research keeps revealing new insights about these amazing structures that orbit the planet. The Cassini Huygens, I'm not sure how to pronounce that, collaboration between NASA and the European Space Agency and Italian Space Agency. This ambitious journey to uncover the cool mysteries of Saturn and its stunning rings when the spacecraft arrived in 2004, kicking off a 13-year exploration that wrapped up in 2017. So that's pretty fascinating. It says the mission also gave deeper insights into Saturn's many moons, revealing the unique composition and geological features. For example, Enceladus, one of Saturn's icy moons, has geysers that shoot out water vapor and organic materials, hinting at the possibility of subsurface oceans. Thanks to Cassini-Huygens' mission, scientists gained valuable insight into the intricate dance of moons and rings around Saturn, completely transforming our understanding of the planet and its unique traits. Saturn's moons and magnetic field. There is much more to Saturn than just those incredible rings. In fact, Saturn boasts a minimum of 145 moons, each with its own unique characteristics and mysteries. Among these, Titan, the second largest moon in the solar system, truly steals the show with its thick atmosphere and intriguing surface. Interestingly, Titan has a magnetic field that, while weaker than Jupiter, is stronger than Earth's, indicating complex interactions with Saturn's magnetic environment. Titan radiates powerful radio waves, particularly from its spectacular auroras at the poles, which can provide valuable insights into both Titan's atmosphere and the overall dynamics of Saturn's magnetic field. The upcoming Dragonfly mission will search for life on Titan. That said, Titan's mysteries pale in comparison to what we might find on Enceladus. Cassini discovered the presence of vital components of life on this icy Saturnian moon. Based on this data, experts have identified crucial organic compounds and a potent energy source, hinting at the moon's potential to support life. Not only does Enceladus seem to meet the basic requirements for habitability, we now have an idea how complex biomolecules could form there, and what sort of chemical pathways might be involved. And that was from JPL, the Jet Propulsion Laboratory, and Harvard. Stargazers, Saturn, and those magnificent rings. To sum it all up, Saturn's rings prepare to vanish from view in March 2025. Stargazers have a unique opportunity to witness this fleeting cosmic event. The rings will align edge-on with Earth, making them virtually invisible and highlighting the dynamic nature of celestial objects. For now, Saturn remains a captivating target for those with telescopes or high-powered binoculars. And I've never seen Saturn's rings, so that's good that they're going to come back, and it's not just a permanent thing. So we'll move on to this. This is a big one. NASA discovers third global energy field as fundamental as Earth's gravity and magnetic fields. NASA's recent mission has unveiled Earth's ambipolar electrical field, crucial for understanding atmospheric dynamics and exploring other habitable worlds. A rocket team reports the first successful detection of Earth's ambipolar electric field, a weak planet-wide electrical field as fundamental as Earth's gravity and magnetic fields, which I looked up ambipolar, and that just means that it goes both ways. First hypothesized more than 60 years ago, the ambipolar electric field is a key driver of the polar wind. A steady outflow of charged particles into space that occurs above Earth's poles. This electric field lifts charged particles in our upper atmosphere into greater heights than they would otherwise reach and may have shaped our planet's evolution in ways yet to be explored. Using observations from a NASA suborbital rocket, an international team of scientists has, for the first time, successfully measured a planet-wide electric field thought to be as fundamental to Earth as gravity and magnetic fields. Known as the ambipolar electric field, scientists first hypothesized over 60 years ago that it drove how our planet's atmosphere can escape above Earth's north and south poles. Measurements from the rocket, NASA's Endurance mission, have confirmed the existence of the ambipolar field and quantified its strength, revealing its role in driving atmospheric escape and shaping our ionosphere, a layer of the upper atmosphere more broadly. Understanding the complex movements and evolution of our planet's atmosphere provides clues not only to the history of Earth, but also gives us insight into the mysteries of other planets and determining which ones might be hospitable to life. The paper was published August 28, 2024, in Nature. An electric field drawing particles out to space. Oh, there's 3 videos on this article in SciTech Daily, and the first one I can't play because it has music, but the 2 other ones I can, but I'll link it so that you guys can watch it. It's like a 4.5-minute video. Pretty good, pretty interesting, but yeah, I just can't put any of it because it has music, so we'll get hit by the copyright because I don't have access to that music. All the music I own, like I purchase basically like out of my own wallet, so I have the rights to use that stuff. So that's how that works. But since the late 1960s, spacecraft flying over Earth's poles have detected a stream of particles flowing from our atmosphere into space. Theorists predicted this outflow, which they dubbed the polar wind, spurring research to understand its causes. Some amount of outflow from our atmosphere was expected. Intense, unfiltered sunlight should cause some particles from our air to escape into space, like steam evaporating from a pot of water. But the observed polar wind was more mysterious. Many particles within it were cold, with no signs they had been heated. Yet they were traveling at supersonic speeds, that's pretty crazy. That's fascinating, that they would be cold and going faster than the speed of sound. Something had to be drawing these particles out of the atmosphere, said Glenn Collinson, principal investigator of Endurance at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and lead author of the paper. Scientists suspected a yet-to-be-discovered electric field could be at work. The hypothesized electric field generated at a subatomic scale was expected to be incredibly weak, with its effects felt only over hundreds of miles. For decades, detecting it was beyond the limits of existing technology. In 2016, Collinson and his team got to work inventing a new instrument they thought was up to the task of measuring Earth's ambipolar field. How the ambipolar field works. So this is where it gets kind of complicated. I'm going to do my best, but I'm not a scientist. So scientists theorize this electric field should begin at around 150 miles or 250 kilometers altitude, where atoms in our atmosphere break apart into negatively charged electrons and positively charged ions. Electrons are incredibly light. The slightest kick of energy could send them shooting out into space. Ions are at least 1,836 times heavier and tend to sink toward the ground. If gravity alone were in play, these two populations, once separated, would drift apart over time. But given their opposite electric charges, an electric field forms to tether them together, preventing any separation of charges and counteracting some of the effects of gravity. This animation starts with a close-up view of the ionosphere, represented as a blue arc over a slowly rotating Earth, which is not to scale. The view then zooms in, showing nitrogen that comprises most of the atmosphere. Panning upward, the view then shows atomic oxygen, a lighter element that populates the upper portions of the ionosphere. When photons from the sun collide with these gases, electrons can be knocked loose. As the atoms and molecules lose electrons, they become positively charged, making them ions. This process is known as ionization. After the oxygen atom becomes ionized, the view changes to show a collection of these ionized gases known as plasma. When there are equal numbers of electrons and ions, the plasma as a whole is neither positively or negatively charged, but neutral. However, the magnetic pull between the individual particles tether them together by an electric field like glue. This field is known as an ambipolar electric field. This electric field is bidirectional or ambipolar because it works in both directions. Ions pull the electrons down with them as they sink with gravity. At the same time, electrons lift ions to greater height as they attempt to escape space, like a tiny dog tugging on its sluggish owner's leash. The net effect of the ambipolar field is to extend the height of the atmosphere, lifting some ions high enough to escape the polar wind. Okay, so all of that was a description of this 29-second video that we're about to watch, which has no sound, but I'll try to describe it for the people listening. So it starts off with the, and there's going to be clicking because I'm pausing it because it's so fast. It starts off with the ionosphere represented as the blue arc over a slowly rotating Earth, and then it goes to nitrogen. So we'll wait for it to go to nitrogen. There we go. They're all nitrogen molecules floating around the atmosphere. Then it goes up higher into the atmosphere, and it shows us the oxygen molecules, which are lighter. That gets hit by the sun photon, electron goes out, and the atom becomes positively charged and ionized, and the electron attaches to the atom. And that's the first step in this electric field inflating the ionosphere. So then we're going to move on to the second one. The sparkling blue haze surrounding Earth represents the plasma in the ionosphere. At the beginning of the animation, the ionosphere is dense and close to the Earth, but when the ambipolar electric field is applied to the plasma, the ionosphere inflates, making it taller. This happens because the tug from the energized electrons, which are connected to the heavy ions, slightly overpowers the force of gravity, creating an upward lift. Hydrogen ions, however, are so light that the field's upward force is 10 times the force downward of gravity. Wait, I don't think I read that right. Hydrogen ions, however, are so light that the field's upward force is 10 times the downward force of gravity. This accelerates the hydrogen ions upward to supersonic speeds, enough for the ions to escape to space above Earth's magnetic poles. This hydrogen ion outflow is known as the polar wind, shown in the animation as sparkling white lights traveling up the blue magnetic field lines and out of frame. Okay, so here we go. All the ionized electrons are shooting off, and you see how everything's being taken up, and then there's this, as the stronger parts of the magnetic area shoot them stronger, obviously, but So I guess it's showing all of these ionized things being pulled out into space and the atmosphere extending out into space. And it says they had launched it from the Arctic, the Endurance rocket, and that it reached an altitude of 477 miles, 668 kilometers, splashing down 19 minutes later into the Greenland Sea across the 322-mile altitude range where it collected data. Endurance measured a change in electric potential of only 0.55 volts. A half a volt is almost nothing. It's only about as strong as a watch battery, but that's just the right amount to explain the polar wind. And this is a picture of it taken off. Hydrogen ions, the most abundant type of particle in the polar wind, experience an outward force from this field 10.6 times stronger than gravity. That's more than enough to counter gravity. In fact, it's enough to launch them upwards into space at supersonic speeds. Wow. Heavier particles also get a boost. Oxygen ions at that same altitude immersed in this half a volt field weigh half as much. And in general, the team found that the ambipolar field increases what's known as the scale height of the ionosphere by 271%, meaning the ionosphere remains denser to greater heights than it would be without it. It's like a conveyor belt lifting the atmosphere into space, Collins had added. Endurance's discovery has opened up many new paths for exploration. The ambipolar field as a fundamental energy field of our planet alongside gravity and magnetism may have continuously shaped the evolution of our atmosphere in ways we can now begin to explore. Because it's created by the internal dynamics of an atmosphere, similar electric fields are expected to exist on other planets, including Venus and Mars. Any planet with an atmosphere should have an ambipolar field. Now that we've finally measured it, we can begin learning how it shaped our planet as well as others over time. Which makes me think of Mars because it doesn't have an atmosphere or magnetism, allegedly. So I would like to hear what they think about that, and looking forward to more information about that. Again, it's one of those things that it was all around us. We just had to go and actually look for it, which is pretty fascinating that they had hypothesized this for 60 years and we've only just now confirmed it. But we'll move on to bacteria, specifically human mouth bacteria, reproduce through a rare form of cell division, which this one's going to get fascinating, but a little bit creepy crawly for people that might be a germaphobe. It made me need to go and brush my teeth. I'm sure that it'll make you go and brush your teeth after this too, but it is really fascinating, but pretty kind of yucky at the same time. But cool in that we're like a universe of things living inside of us. We have so many millions of different bacteria and organisms living on us. You know, we have arachnids living on our face and our eyes, and then we have these other bugs inside of our mouth. But one of the most diverse ecosystems on the planet is closer than you think, right inside your mouth. Your mouth is a thriving ecosystem of more than 500 different species of bacteria living in distinct, structured communities called biofilms. Nearly all of these bacteria grow by splitting or dividing into two, with one mother cell giving rise to two daughter cells. New research from the Marine Biological Laboratory in ADA Forsyth uncovered an extraordinary mechanism of cell division in Corynebacterium matricodi. I'm probably not pronouncing those right. I'm going to do the best I can. One of the most common bacteria living in dental plaque, the filamentous bacterium, doesn't just divide. It splits into multiple cells at once, a rare process called multiple fission. The research is published in the Proceedings of National Academy of Sciences. The team observed C. matrodi cells dividing into up to 14 different cells at once. Wow, 14 cells in just one reproduction cycle, depending on the length of the original mother cell.